Write an equation for the graphed function that is a transformation of the graph of one of our toolkit functions. We're given this graph. I see that V shape in the graph, and so this looks to me to be a transformation of the absolute value function. So recall that the basic function, absolute x, is that V-shaped curve with the corner point at the origin. And so this is a transformation. It appears, right, so if we find that corner point, that's at -1, -4. So I've taken this function and I've shifted it left 1, I've shifted it down 4, but I've also flipped it over, and I might have also adjusted the scaling. All right, so let's take those one by one. To shift left 1 unit, I have to replace the x with x plus 1. So I have now the absolute value of x plus 1. To shift down 4, we subtract 4 outside of the function, outside of the base function. All right, now the other issue is the scale factor, and I expect there's also a multiplication by a negative in here because the basic function's been flipped over, right, has that vertical reflection. So we'll take that all into account by writing the function as f of x equals sum a times the absolute value of x plus 1, then subtract 4. We need to figure out that a value, but I expect it to be negative. So let's find another nice point on the curve. Let's see. I see the point 3, -6. I'll use that point. All right, so letting x equal 3 and -6 replace f of x. -6 is equal to a times the absolute value of 3 plus 1, and subtract 4. The absolute value of 3 plus 1, well, 3 plus 1 is 4, and the absolute value of 4 is 4. So I have -6 is equal to a times 4, subtract 4. Solving for a. Let's add 6. Let's add 4, sorry. Add 4 to both sides. -6 plus 4 is -2. -2 is equal to a times 4. And divide by 4. Then a is -1/2. It's a negative value, which is what we expected because of the vertical reflection. And so now let's revise our function. Putting that all together, a is -1/2. So my revised function, f of x, is -1/2 absolute x plus 1, subtract